Let's see more about equilibrium. Consider a gas with volume V. The pressure on the bottom side of the piston is P, which is the internal pressure. From the top, the same amount of pressure, the external pressure, is acting downwards. If these two pressures are the same in magnitude and opposite in direction, only then the piston can stay stable. It is called the mechanical equilibrium. Basically, forces are balanced. Otherwise, there will be a movement of the piston, which means the gas is not in stable state. Similarly, if the internal temperature and the external temperature or the temperature of the wall are balanced, then we have thermal equilibrium. Otherwise, there will be some heat flow. Now consider two solid copper-nickel alloys at 800 degrees Celsius inside a furnace. Both are made of mostly copper. One has 20% nickel and the other has only 10% nickel. Now join the two pieces, give some time, what happens? The nickel concentration becomes uniform, 15% throughout. If we plot it in a graph of concentration versus distance, initially the left side had high nickel and the right side had low nickel. After some time the final state is uniform concentration of nickel. What do we learn from this case? If there is a concentration difference, it is going to become uniform. But is it always true? No, there are several material systems where a concentration difference actually grows. For example, consider copper-cobalt alloys instead of copper-nickel alloys. One has 20% cobalt and the other has 10% cobalt. In fact, it is difficult to dissolve cobalt in copper and make such alloys. Let's say somehow we made it. Join the two pieces, give some time. What happens? Forget about cobalt becoming uniform. The concentration difference actually increases. In a graphical form, the initial state was like this. The left side had high cobalt, the right side had low cobalt. After some time in the final state, the left side has even higher cobalt, the right side has even lower cobalt. How to understand this? Instead of concentration of cobalt, we can analyze what is called chemical potential of cobalt. We will see about it in a future video. What happens when we have a chemical potential difference? It always becomes uniform. Whether it is copper with nickel or with cobalt, it becomes uniform. That is called chemical equilibrium. So equilibrium state means that a system is in mechanical equilibrium, thermal equilibrium and chemical equilibrium. There is another concept called phase equilibrium, which is often described as a separate one. For example, at 0 degrees Celsius, liquid water and solid ice coexist, which means two phases are in equilibrium. But phase equilibrium can be explained using these three equilibriums and need not be a separate one. See you in the next video.